So hi everyone. My name is Erden. I'm a community manager at StarTree. StarTree is a company, a startup doing real-time analytics based on Apache Pinot, founded by the original creators of Apache Pinot. And I'm extremely excited to be here today with Dunit and Mark. Both are developers, senior developer advocates. Mark in StarTree, Dunit in Redpanda, and also dear friends. So we'll start the meetup of building a real-time analytics application with Redpanda and Apache Pinot. Feel free to use the chat during the meetup. In case there is a question, I will pop it, so it will pop on the screen. Mark and Dunit can reflect it, can reply. And also, after 45 minutes, something like that, maybe earlier, we will leave time for your questions as well. I will share the links to Redpanda and StarTree communities Slack. So if you have more questions after the meetup, you can also always ask those questions there. And yeah, I will pass the mic to Mark and Dunit.
Cool. All right. Hello, everybody. Yeah, so like you had insights, we're going to be showing you how you'd go about building a real-time analytics application with Redpanda, Apache Pinot, and actually also a Python library called Streamlit as well. So yes, I'm Mark, a developer advocate at StarTree. Yeah, I guess there's not really probably much more to say on the intro, so let's skip the intro. Let's get into it. And Dunit will come in when it is his time. So let's just start with a definition so we kind of roughly know what we're talking about. So this is the Gartner definition of real-time analytics. So they say it's the discipline that applies logic and mathematics to data to provide insights for making better decisions quickly. So you're like, okay, well, some of that was like, okay, I don't really know what is it talking about, but the bit that's in bold is kind of the interesting bit, right? So we're provide insights for making better decisions quickly. So that's like the whole point of the talk. Now, how do we get to the point where we can make those insights and help make those decisions? So hopefully you're reasonably familiar with the idea of events. So events are things that happen. They're usually, they will likely have been in the past, like unless you're a bit psychic of predicting some events going to happen in the future, and they are representing some facts of a thing that happened in the past. So it might be that you logged into this meetup. It might be that I bought something from the shop. I ordered a pizza, like some sort of event, and often it will be captured in JSON, for example. So like as a structure, like a nested event, and it has some information. It will have some facts that happened at a time. And so we have those events. We often have lots of them, like a stream of those events. And the idea is that we want to figure out like something. What can we do based on that event? So it's happening. Like, okay, that's interesting, but what can I do as a result of it? So we want to try and gain some insight into the event, like some insight into, hey, you're joining this event. Maybe I can suggest you another event. Maybe I can tell you, I don't know, more information about the speakers. Maybe I could do something based on that. And so that's where we get the action. So we're kind of trying to like, so if somebody was I don't know, doing a search for something, let's just say they're searching for a pizza, maybe we can get up a voucher. Hey, go and buy a pizza from here. Yeah, I don't know why. Another good one would be like if we see like an anomaly on an IoT device, like we suddenly see like a spike in a value that an IoT device is producing, maybe we could figure out like why on earth is just before the meetup, Dunit and I were talking about the cost of energy, particularly in Europe, is currently astronomically high. So we're kind of watching, like we've got like this smart meter in our house, and it kind of gives you a reading sort of for the electricity, every 10 seconds roughly, it tells you this is your current expenditure per hour. And so when we see it go up, we're like, what the hell, what on earth is going on here? Like, can we do something to get this down? And then often you just realize, oh, actually, it's something that we've got running that is very energy intensive. But sometimes you see like, oh, I've left on something by mistake, so I need to go and turn that off. So yeah, the idea is we see an event, it's telling us something, and we can fix it now. Like rather than in the electricity example, we wait until tomorrow and we get the information and we're like, oh, we just spent £10 on heating something that we didn't need to heat. So can we do something in the moment to help us in some way? Be it to buy something, in my case, to reduce the cost of electricity on a website to get people to use it more often, or more frequently, exactly. And so the value of data when we're talking about analytics, the most value in it is right at the start in our world. So there certainly is value in looking at historical or batch data as well. But that tends to be, that's not really the area that we're going to be covering in this talk. That tends to drift into the world of like Redshift or Snowflake, or those like sort of data warehousing tools where you put in a bunch of compute on data for like a long period of time and learn something from that data. Whereas we are much more interested in like sort of soft real-time data, so data that just happened or maybe just happened like a few hours ago, like that sort of area. And so the reason that we're interested in it is because we have so we're developing or engineering some sort of software solution to something, and there are people who are interested in the data, like, and being able to do something with it in real time. So it could be the analysts. So imagine we're running that pizza shop. So the analysts are looking at a dashboard, seeing all the data is coming in, and they want to know like what's happening. Like, is there like a is there something that we need to do? Like, can we respond if something's going wrong in a particular area, or there's a surge in the orders for a particular item? Maybe the management would like to know, they want to see like, what's the revenue? Like, is the revenue like keeping up? Are we seeing like an anomaly? Like, is there a dip for some reason? And can we do something about that to try and fix it before it goes on for too long? And then finally, the users are interested in it as well. So it might often be data that they are generating, and then we're sort of like rolling it around again and building a product based on that data. One quite nice way of thinking about this is when you're building these applications is there's this quadrant of the types of things that you can build. So they kind of cut along two axes, right? So the x-axis, we've got internal applications and external applications. And then on the y-axis, we've got machine-facing and human-facing. And so if we start from the left-hand side, so in machine-facing internal, these would be tools for observability. So it's like, can we feed some real-time data into a tool that can do anomaly detection on like our rack of, maybe not a rack of servers, but our AWS estate? Like, can we see what's going on there? Like, are we seeing some spike in CPUs somewhere? Are we seeing like a DDoS attack somewhere? Like, can we detect that like when it's happening? So that's the sort of internal facing, internal and machine facing. Where we're going to be focused today is down in the bottom left-hand corner, which is internal and human-facing. So here is like we're building a dashboard, and maybe maybe we're going to have less users are going to be using it. Like, it will be like a certain set of internal to a company users, but we want to be able to move on from, hey, here's a dashboard based on running like a query on yesterday's data, to, hey, here's a dashboard based on data that just happened now, right? That's the movement that we're making. If we come over to the right-hand side, we've got external and machine-facing. So here it's like the users are now like, for example, on a website or mobile application. But the way that the data is being interacted is that there's a machine somewhere in the flow, and it's doing something with the real-time data before it's feeding it back to the user. So it could be, hey, I'm seeing like somebody's adding these things to the cart. I know that people who add those things to the cart in the last 1 hour, they're also buying this other thing. So can I get that recommendation on there, like as they're in the order flow? So you'll see it, but it's often like you might see it in the flow of some like apps that you can, like food purchasing apps, but it's often, I guess it's like more historical data. It's like, hey, people who buy this sometimes buy this, but it's like, hey, can we go further than that? Can we be like, is there some special thing that people are doing like specifically now that we can try and get more people involved in? And then finally, if we move down into the bottom right corner, we've got like the idea, and so like this sort of thing exists already, right? Like an order tracking service. So I order my my dinner from, I don't know what other like worldwide food delivery apps, Uber Eats, DoorDash, Just Eats, whatever one it is. And then I want to see like, when is it going to come? Like, show me on the map, like where is the delivery? Like, how close is it to coming so I can get ready for my dinner? Or it could be just like, hey, I want to see like what's happened to the process of that order? Like, is it being cooked? Like, is it like where exactly is it in the flow in the kitchen? And so I just want to run through some examples of applications that already do this. So LinkedIn is one of them, and so that's the origins of Apache Pinot. And so one of their tools is who viewed your profile. So maybe if you use LinkedIn, you will have seen this, and you click there and you see, oh, some people are looking at me, and it's kind of more or less up to date to right now. So if I were to go and look at Dunith's profile, if he went on the page, he'll see like, hey, Mark looked at the page. And if you have the premium feature, it shows even more insight into what those people are doing. And so you can kind of see on the right hand side, we've captured like this sort of like the intent of this in this one being a user facing one is it needs to be able to handle lots of users maybe looking at that screen at the same time and handling a lot of queries per second to give like the up-to-date view on it. The news feed is another one. So this is like more like, hey, so the other one was, hey, I'm curious, who is looking at me? Like, are there some opportunities for me that I can take advantage of right now? This one is, hey, I want people to like build a community of people who have an interest around, it's often around a technical area, I guess, like in this picture here. It's like, hey, can we interact with the Apache Pinot committers? And so it's got like their names on there, and it will rank if you've been doing clicking on stuff or liking stuff from Keysure, it's probably going to go, hey, look, here's another one that you might be interested in. And we try and build like a interaction with those people. And I guess generally for LinkedIn, the idea is, hey, can we make people use the product more? And then finally, let's have a look at the talent pool report. So this one is kind of weird because it's external, but it's a much more limited set of people who can view it because it's only people who are paying for the recruitment product that they have. And so they're trying to see like what are the real-time trends of what people are doing, where they're moving, where the jobs are available, where people are available, and so on. I say this one must be a really, really useful tool to have, like given some of the tech layoffs and the really big companies in the last 2 months or so. And then one more. So let's have a look at this one. This one's Uber Eats. So this is the restaurant manager. So I guess this one's kind of a little bit like what I've been talking about in the examples before. So they have a dashboard for if you have a restaurant on Uber Eats, you get a dashboard and it's like, hey, here's the revenue, what's happening in the last weeks, compares it to the previous week, compares it to rate, like you can compare it to specific day ranges. But the cool thing here is you can also see like, hey, which orders have we done wrong? Where have we got downtime? Which orders have we missed? And can we actually go and fix something about that? And then you also get like, what's the sort of real-time feedback people are giving us on the menu? And so if we want to build one of these systems, how do we do it? So there are a few properties that they have. So first of all, we need to be able to get data in quickly. So it's coming in from somewhere like our event generator, be that it's coming from like an event tracker, like Segment or Snowplow, or maybe it's being like we're ingesting that data into our streaming platform using a SDK, or perhaps it's coming from an OLTP database and we're using change data capture to get it in. We need to be able to get that in quickly, and then the next thing is, once we've got it in quickly, we want to be able to query it quickly, right? So we want to be able to write like queries against that fresh data, and they should be able to give us sort of OLTP query speeds, so it's sort of millisecond query speeds, but on OLAP data. So we're looking like scanning across like lots of data, but can I get like a very, very fast answer to the types of questions that, for example, we might ask for a dashboard. And then finally, as I was sort of alluding to in the last time, we want to be able to do this at scale. So we want lots of people to be able to do it, or perhaps it's fewer people, but doing lots of queries. So that either way, the intention is lots of queries coming through. And so we're going to do a demo showing how you would build something like this. And we're going to be doing it using, I guess, yeah, as the title kind of implied, we're going to be using Redpanda and Apache Pinot. And between these two tools, we're able to achieve the criteria that we talked about. So we can do sort of real-time ingestion, we can deal with high dimensionality of data, we can deal with a lot of that data coming in a highly available, scalable, and cost-effective manner. And then sort of when it's coming out the other side, we can do those thousands of queries with low latency and a few seconds freshness. So I'm going to let Dunith talk a bit now about what Redpanda is, where it fits into this ecosystem.
Right. Thanks, Mark, and good morning, good afternoon, and good evening, everyone. I'm Dunith Dhanushka, Senior Developer Advocate from Redpanda. For those who are new to Redpanda, let me introduce you to Redpanda real quick. So basically, Redpanda is a streaming data platform, API compatible with Apache Kafka. So what do you mean by that? So that means if you already have a Kafka producer or a consumer application, it can seamlessly work with Redpanda. So it's a drop-in replacement for Kafka. So although Redpanda and Kafka work similarly in behavioral, there are drastic differences in the architecture. So there are many reasons behind it. So first off, Redpanda is written in C++ and it leverages this C* framework for most of its operations. So due to that, also Redpanda and Kafka, so there are so many differences. So first off, Redpanda can offer a better performance compared to Kafka. So that's one advantage because Redpanda is written in C++ and it can work closer to the hardware. And based on the efficiency of the C* framework, it can squeeze the maximum performance out of modern hardware like SSDs and NVRAMs and these kind of hardware devices. So that's one thing. So performance is one thing. Secondly, Redpanda doesn't need that much of hardware resources. That means Redpanda occupies less hardware footprint compared to Kafka because of the C* framework and the underlying operations. And finally, Redpanda comes with more developer-friendly and operator-friendly features. Like, for example, in Kafka, you deploy the schema registry and HTTP proxy separately, but in Redpanda, it is built into the Redpanda binary. So you don't have to deploy them separately. In addition to that, Redpanda comes with its own visual console so that you can visually debug your Kafka applications. It comes with its own RPK, or we call it CLI tool. So there are many other options compared to Kafka in Redpanda. So as we dive deep into the demo, we'll unpack each feature eventually. So that's, yeah. And then Mark mentioned about how these components fit together. That means Redpanda and Pinot. So in a typical data pipeline, Redpanda stands first. So that will accept these events coming from different environments like event trackers, change data capture, and SDK clients, and everything will eventually land on Redpanda in real time. And then we can configure Apache Pinot to work with Redpanda as much as the same way you work with Apache Kafka, because they have the same read and write interfaces. So that's the benefit here. So you will see that in action in a couple of minutes. All to you, Mark.
Yeah, I just wanted to check. Can everybody actually see what is on the screen? So Nagarjuna was saying this is just a black screen. I mean, I can try to turn it off and turn it on again. I don't know whether it will make a difference. There? I don't know. You have to tell me in the chat. I don't know whether that makes any difference. For me, I can still see it on the window over here.
Yeah.
Okay.
Yeah.
Then I don't know what's maybe you need to try and refresh hard refresh the hop-in window or something. Okay, let's carry on. So that's Redpanda, and so then we have next thing is what is Pinot. So Pinot sort of sits in the middle. So it's an OLAP database. As Dunit said, it can ingest data from streaming platforms such as Redpanda, Pulsar, Kafka, whichever one you're using, and then it takes that data. It can build pre-aggregates. It can pre-aggregate the data. It can put indexes on it, and it effectively gives you a SQL. Okay, cool. Seems like most people can see it, so that's good. So you effectively build a table on top of the data that's coming from, like, for example, from Redpanda, and then we can query that using a SQL implementation. So let me just explain the architecture of how this is going to glue together once the data comes. So it's going to come into Redpanda, and then we're going to get it over into Pinot. And so there are three main components. We've got the Pinot controller, we've got the Pinot server, and then we've got a Pinot broker. So the Pinot controller is the manager of the cluster. So it takes care of managing, like, where are the data that's coming from the different Redpanda partitions, rather. Where's it going to go? It's going to go into like some segments in Pinot, and the controller is going to control where exactly do they need to be placed. So for example, here we go 1, 2, 3, 4, and maybe we have a replication factor set up, and it's going to put the second copy on a different server. And all the metadata that Pinot uses is managed in Zookeeper. So Pinot controller interacts with Zookeeper, and then we have the server, and that has all the data. And then, as I say, finally, we have the broker, and so the broker is where the queries come in. So the query comes into the broker, it does some scatter gather, like type pattern, sends out the query to the appropriate servers. They then come up with a result based on their data, send it back to the broker. It aggregates what it got from all the different servers, and then we get the result coming back to the client. So demo time. Somebody asked already, so this Marcel asked if we can have the repository. So this is where it is. I've already pasted it 4 minutes ago, or is it maybe 5 minutes ago. If you look at 10 or 17 past the hour, I guess 47 past maybe for doing it. Oh, there we go. That's the link. And so if you want to follow along, the instructions are all in there. Yeah, I know. Zookeeper never dies. Zookeeper is always there somewhere in the architecture, isn't it? I mean, even I think the latest Kafka doesn't have Zookeeper. So people loves to hate it. I used to work at Neo4j for a long time, and we had Zookeeper as well, and then took it out. So maybe there'll be some project in the future where Pinot removes it as well. So like I mentioned before, we're going to be building a real-time dashboard that fits into the bottom quadrant. And here's a diagram showing the architecture that we're going to build. So kind of like what Dunith said, we're going to query some data from a streaming API. We're going to get it, and then the data, so like the source data, is going to come into Redpanda. It's going to be the source of truth of our data, and then it's going to send it out to Pinot. And then once we've got it in Pinot, we're going to do some queries from a tool called Streamlit, so that we can like visualize it in a better way. We're going to be using Wikimedia's recent changes feed. So this is a continuous stream of the changes that people are doing to Wikimedia properties. Interestingly, it's internally in Kafka, but then they take it and they expose it over HTTP using this protocol called Serverside events, which looks like this. So you get 3 properties. You get an event, an ID, and data. So event is, I always see event as message. I never see it as something else. And then they have an ID for each message. And then finally, they have the data itself, which is like a nested JSON structure. So let's have a look. So like I say, if you want to follow along, maybe I'll open it here so we can just have a look. There we go. So this is what we're going to be doing. If you're using Mac M1, you can it's all in Docker. So we have a Docker Compose script. It has Mustafa. The link is a little bit up. The slides, yeah, I guess the slides aren't linked anyway yet, but more or less, if you follow this, that's what we're going to be doing. Well, Yarden will share the slides afterwards. So we've got Zookeeper at the top. Then we've got Redpanda next. So this is all the stuff you need for Redpanda, all the various ports, the advertised address. Usually you'd be obviously using multiple nodes of Redpanda, but for this example, we're just using one. And then we've got the Redpanda console. So this is like the UI for managing Redpanda. And we're gonna have a look at that in a minute. And then finally, we've got the Pinot components. We've got the controller, we've got the broker, and we've got the server. And that will all, if you run this one, so for the M1 Mac, you need this suffix. Oh, really? Hang on. Let's try. Hang on, I'll send you a link again. Maybe this one. Try that. Okay, so let's start by having a look. So we've got it, it's already all spun up. And we're going to start by taking a look at the data. So we've got this. Yeah, I can get away with just showing it on here. This is just so it's big enough. This is a Python script that queries the Wikimedia API. So you see here, we've got the URL. I can put it in my browser just so you can see what it looks like. So this is what you get. You get loads and loads of these messages. It's like kind of 50 to 100 per second. You can see they're all coming through. My browser will eventually get angry with me for printing so much stuff. But effectively what we do, we use the Python requests library to make a wrap around it. We say, hey, I've got a stream. I want to get back, I accept like getting back an event stream. And then we're going to wrap that into the single server-side events client, and it will give us basically an infinite stream of events. So if we call Python wiki, and you see like all the events coming through, pretty much the same as what we had before. We could run it through JQ if we wanted to see like oh no, I don't have JQ on here. Okay, never mind. But you could basically see like if we stop that, you can kind of see that there's one event. So you've got the schema, it's got a bot, it's got a comment ID, it's then got a bunch of stuff under meta, parsed comment, and there's loads of stuff to play around with. Okay, so then once we can get the data from that streaming service, but we're just printing it out to the console at the moment. What we actually want to do is get it into Redpanda, right? So this is a script for getting it into Redpanda. So you see, you can actually, as Dennis was saying, because it's compatible with Kafka, we can actually use the Kafka producer to get the data in. So we say, hey, I want a Kafka producer. Tell it where my Redpanda is running. And then I can ingest the data into there. Before we do that, I guess we should create a topic there. So Dennis, I'll let you guide me through. So this is the Redpanda UI.
Yes, yes. Like Mark mentioned, so he showed you the Docker compose configuration, right? So this component is called Redpanda console, and it is available for free. So I'll post the link to work with this. So there's a dedicated Docker compose file, so you can get started with that. In this console, you can do administrative tasks and some debugging tasks related to Redpanda. For example, here you can see Mark is creating a new topic. Actually, topic creation is optional prior to publishing data. So by configuration, you can instruct Redpanda to automatically create topics when you publish a new stream. But it is up to you. So at some point, you need to create topics with more advanced properties, like how many partitions, what's the replication factor. So the underlying configuration is pretty much exactly same to the Kafka configuration model. So like Mark is doing right now, you can configure it.
1 gigabyte of data, one day. What's compact? What does that do?
So basically, compacting means as the time goes, you have to compact, or how do you call it? You need to group all the events with the same key to only to contain the latest or the most recent event. By that way, we can save that much of disk space. Other thing is,
all our event IDs are going to be unique, so we probably don't get much benefit in this example.
Right. So the main objective of compacting is to save the disk space and to retain more data. So other option is to purge data when there's some point in time passes.
So should we create this?
Yes, go for it.
All right. So
Nice.
we've got wiki events. So at the moment, no data. All right, next step, put some data. So what this script is going to do, it's going to take one of those events from the stream. It's going to build a payload. It's going to get the meta ID as the key that Dennis was just talking about. And then the value is going to be the a JSON string representation of the events that have come in. Every 100 events, we will flush it. So let's see if we can get this to work. So if we Let's have a look. The events are coming.
It's real time, right? And these are actual events, right, Mark? So
Yeah.
if you just go and edit some Wikipedia article, it will show up as a change event here. So
right, what do we do now? So you can kind of you talk me through. What should we do next? What do we do on the screen?
So this is the first thing. So here you can see your topics and you can see actual message content. So this is just for JSON data, but if you are sending other formatted data like Avro or protobuf, you can see the actual message content within the console itself. It is pretty powerful, including its.
Hey, look, I can see something here, right, as well, though, even under value. Or you somewhere else.
Yes. So basically, if you go to this filter page, so you can filter messages by partition. Yeah. And also you can set a filter condition, for example.
So what should I write?
Something like, I don't have something in top of my mind, but just
partition ID. Oh, here we go. Examples.
Yeah. You can check for the attributes like payload attributes, like if this price greater than this value, then only show me those values likewise.
Does it do this? Like one partition 2? Yeah. Did I do it wrong? Oh, how come it still shows me 0?
If you go to this partition drop down in the top.
Here.
Yeah, if you go to no, I mean if you go back to the previous view and go to the filtering view, I mean the partition start offset.
So what should I type? So partition ID?
Yeah, so just
2?
Yeah. Just
0?
No, if you go to this drop down set of drop downs on top of that, just above the
here.
Not the filter, not the filter.
Yeah. Oh, not the filter.
Yeah. You know, this, you can see start offset, the max number of max requests, and if you can disable the filter, you can.
Yeah.
Just turn off the filter. Yeah.
Yeah, it's off. Oh.
Yeah. And then you can filter by partition. There's a partition drop down. Just left hand side. Yeah.
Oh yeah.
Yeah.
2.
You can see how many partitions.
There we go. There's all the one at number 2.
Yeah.
Yes. 0.
And you can also switch between the offsets. Like if you want to see the latest messages or you want to see the earliest messages.
So like there's the oldest ones. When are they
and
from?
Then you can see the different consumers, consumer groups, what are the access control list configurations.
Yeah, I guess we don't have any consumers at the moment, right?
Yes. And then if you go to the sidebar in the left, and if you click on the schema registry, you can see the built-in schema registry. So if you are sending Avro or protobuf schemas, formatted data, you can register your schemas here first, and then it will show up here. And then the console will use this schema registry to deserialize this incoming data, and the console can show its content to you. So it will be very helpful when debugging your applications. And then if you further go down in the sidebar, you can see the different consumer groups and their metadata like assigned partitions. You can see the security, what are the typical access control list. You can impose on certain topics. So there are many things. You can. I'll share a link to get started. So I'll let Mark continue on that.
Cool. Marcel, this is being recorded. Okay, so right, we're running that. Okay, so the data's going in, and we can kind of see that it's making its way into Redpanda, so that's great. It's all working how we wanted. You can see the messages are coming in quite quickly. So next thing we want to do is we want to get that into Pinot so that we can then query the data. Although actually I should say before that, it is possible. There's this quite neat tool that Judith forgot to mention called RPK, a Redpanda Keeper. Panda Keeper, which allows you. The problem with the name Redpanda Keeper is that it always keeps on showing you red pandas.
That's a problem.
Where's it gone? RPK.
Let me paste that into chat.
There you go. I'll put it under here. So there's a command line tool called RPK, which you could have used. We could have used it. For example, we could use it. Let's create another topic for no reason really, but we could call. So we could say, hey, create another topic with 5 partitions. And if we come back to our Redpanda UI, you can see now we've got another one configured. You can also query the existing one like that. So for example, I can say, if I copy this command, I can say, hey, show me the one that we've already got there. Oh yeah, Marcel, sometimes I've seen that as well. Yeah, maybe we need to update it to just say latest. It's weird. But you get, so you get this is the name, it tells you some configuration that we set up. And then finally on the partitions, you can kind of see, I mean, in our case, we've only got 1 machine, so this is not really showing us anything, but you can see the sort of offset start where we are now. I guess if we run it again, this should go up, 3643, 3656. You see it keeps on going up, so we can get a view of data that's going in, which is pretty much the same as what you can see on this screen here. Okay, so when we are working with Pinot, what we need to do is, I should say the other thing you can do is you can actually consume the messages from here too. So if you wanted to get all the messages coming through, you can do that. A bit prettier. So there you go. Those are all the messages. So kind of similar to what you could do with. You can also use KCAT if you wanted to. You can use. That works as well, right? Because of the whole Kafka protocol compatibility. No, wait, let me kill it though. I don't know what I've done. Has it stopped? No. Let's kill the tab. Okay, right. Next thing, we want to look at Pinot. So where do I have these? Are they under config? Yeah. So with Pinot, you create a table. And in the table, you need to kind of say, what fields have I got? So, well, first of all, name the schema. So the schema is Wikipedia. Then you can name your columns or fields. And they use the terminology from data warehousing. So we have dimensions. These are generally things that you might be filtering on or grouping by. So we've got the ID, we've got the wiki, we've got the user, title, comment, so on. You can have metrics, but this one doesn't have any metrics, so we don't have that. But then each one, if you're doing real-time data ingestion, you need to also specify a timestamp field. So in our case, it's called TS. Each of those fields in there will be automatically mapped to whatever is in the source data. So i.e., in this case, the message is coming from Redpanda. But you probably noticed that the names that we've used in there are not exactly the same as what was in Redpanda. So the way that we fix that is via the table configs. If I start from the bottom, so we have some what we call transform configs. So they're kind of doing a little bit of job of what you would do with a stream processor, but just for tiny, tiny changes. So if you just need to do slightly pull out a message that's nested or do like a type coercion of something, this is a pretty good way to do it rather than having to. And I think Redpanda actually has an ability to do things like this in there as well using some, but I think it's more in an alpha or beta state at the moment. So we'll just do this in Pinot for now.
So we have this WASM, or we call it WebAssembly based transformer. So it's currently in the early stages. So basically what it does is you can do small transformations when like massaging optional data. Like you can rename certain fields within the broker itself or the streaming data platform itself without using a third-party stream processor or another tool. So that's one beauty in Redpanda as well. Yes.
If I come back here, so we've got those functions. You could do, you could choose to do this in Redpanda at some point. Then we need to specify the name of our table. We need to say what type of table it is. It can be real-time or offline, although you can also have a table that has both, but you would create them separately. Segment config, so we need to indicate where's the schema and what's the name of the column. And then finally, we can indicate, hey, we're going to be ingesting data from a stream and give it the stream config. Now, like I say, again, we can indicate that it's Kafka because of the Kafka compatibility, and we can use all the Kafka scaffolding. Only thing we need to point out where is a Redpanda running. By the way, the reason this port is different to the one we've been using is because we've got a different port for inside Docker and outside Docker. And then we've got the topic name. So what we're going to do now is we're going to create that table. So we're going to add that table. So let's do that. So it's running like a command, then it executes against the controller, and then it's going to hopefully going to create the table. It's not happy. Invalid table config. Oh, why is the table config invalid? The demo has gone wrong. Let me just have a look. Have I changed something in it? Let's have a look. Table.json. I remember changing it. Oh, I think actually the problem is there a problem? Let's see. I think there was a change in some version where these need to be the same. No, it's the same. Schema. Everything is the same. So what's the problem? Invalid table configs, Wikipedia. I don't know what the... Yeah, I'm not entirely sure what's the issue.
Is that a syntax issue or?
I don't know. It just says invalid table configs, but I didn't think I changed anything. Yeah. Should be pretty much the same as as when I tested it before. Hang on, let's have a look on the main one. Where do we? Let's copy it. I mean, it should be. Let's see if we copy this in. Is there any issue? Let's just try with this table instead.
Yeah.
Actually, it's gonna. Well, hopefully, it's gonna give a different error because I've got the connection to Redpanda is not gonna work. It just says invalid. I mean, this kind of makes sense. This wouldn't work. Redpanda is. Let me just check. So Redpanda is running on. Which one do I need?
1992 should be.
2090, yeah.
1992, yeah.
That one? Oh, 1992, is it? Okay, let's try
You use the internal one first, 291092.
So which one should I use?
So either one should fine. So usually we put 29092. So that means we are in the Docker network and we are trying to connect to
Okay.
Redpanda.
Let's try it.
Yeah. But if you are accessing Redpanda from external client, the port should be 9092.
Yeah, I don't really know. I don't really know what is the problem with this invalid table configs. I mean, we can try and.
Can you use a different name? Different name.
Yeah. Okay. Let's try it. Let's call it just wiki. Wiki. Try that. Good idea. Otherwise, we can try and. I mean, everything else looks kind of more or less what I would expect. Let's see what happens this time. Controller invalid table configs.
Oh.
Doesn't say what is invalid though, so it's not entirely helpful. Let's try in here. So if we,
Yep.
Maybe we can. I forgot. I think maybe you can. Can you add a schema manually in here? Can I paste it in? Let's try. Where's the schema? Let's see what happens if we paste it in. Oh no, that's read only. Okay, so I can't do it there. Let's see schemas. Schemas. Add a new schema. Let's try. Did that work? Oh, it says it worked. Okay, let's see. Yeah. Okay, we got the schema. Okay, let's tables, table configs. It'll be here. So let's grab it. Where's it gone? There we go. See what happens in here. Missing required creator property schema. We've got that, right? Or do you think it changed? Like, oh, do you think it changed? Maybe a schema like that? Or
do we have schema registered already in Pinot?
Yeah, the schema is there, but it says it's missing required creator property, but then it doesn't really. Maybe I can, if I, hang on, I'll undo that. I'm pretty sure that's called schema name. So if we run that, and then I'll get it, I'll copy the curl. Maybe I can read the error easier from here. Let's see. Oh my God, that was not easier. What on earth is that? I got so many. That curl has got so many backslashes in. That surely can't be right. Oh, sorry, I pasted the wrong thing. Okay, here we go. That's better. So if we copy that, let's see what it does. Missing required creator property schema at, but then what is a creator property schema? I don't want to spend forever attempting to debug this, but this is kind of a. I wonder whether there was a change sometime which requires us to put something that we don't have. Creator schema name. I don't really know what we are missing. Schema index at. Yeah, I can't really tell from this where exactly it wants it to be either. I wonder whether this is the problem, maybe. Yeah, I can't imagine it would be this.
This is a strange error, right? So
I know it's unhappy because it already got the table, or no, it's got the schema, but it hasn't got the table. So now it's like complaining that we created the schema. Oh no, what have I done this time? It doesn't have an update. Yeah, maybe we're going to abandon this for the moment, and I'll have to debug it later. So we've got some backup screenshots to show you what should happen if this would work. Ask ChatGPT. Oh, damn helpful. I really don't know whether. You ask it. You've seen what we're doing. Paste it in. See what ChatGPT says. So what should happen, right, if we get this kind of working is Marcel says, I'm not seeing the Redpanda service. Yeah, you need to go on the Redpanda branch, Marcel. Like there's multiple branches for doing this in different things. So
right.
What you kind of see is it loads in these events, and we can kind of see, like you get all the columns, you can then see like the message sort of coming in. You can do sort of, if we wanted to, we could do some grouping queries, kind of, like, for example, find out who's the most popular user. Perhaps unsurprisingly, this is bots. There are a lot of bots updating Wikipedia sort of all the time. And then this is what the dashboard looks like if we would get these bits glued together. So we kind of see the events sort of coming in. Can capture the number of changes being made per minute. In this case, I guess we could change the granularity if we wanted to. You can see how many users are making changes, and then what domains where the changes are being made. And then we can also see who's making the changes. So as I say, it is all bots, but the way that they categorize them is not necessarily all bots. So we sometimes see it. It tells us, like, what does it say? Like, most of them are not bots, right? So 70% are not bots, which is surely untrue. You can also break it down, so you can see the top users and how many changes they've done. So like this is like in a 10-minute spell. Like they change a lot of stuff. Like, and equally, we could break it down and say who's the top bots and who's the top no bots. And you can see, like in the names of the no bots, it's got bot on some of them, like the research bot is not a bot. The NP importer bot is not a bot. I assume these bots are all doing like kind of generic like repeatable changes that need to be done maybe every day or multiple times a day, and they're just going through and doing them everywhere. We can also drill down, so you can kind of do drill down queries. We can say, hey, I want to go down into the domain and show me what domains are being changed at the time this screenshot was taken. We can see it's all Wikidata, the commons area. So Wikidata is their triple store, like the metadata store. So they're kind of capturing data in there. Russian Wikipedia, English Wikipedia, French Wikipedia, and so on. And then even more, we can go down and have a look at the individual users and see what they're doing. So we can see which domains they're changing. And most of the stuff they're doing, these automated bots, is on Wikidata, right? They're doing, I guess, some sort of automated updating of the factual data that the Wikimedia folks are keeping track of. And then finally, you can get the types of changes. So there's edit, there's log, I think there's create, and then there's a couple of other ones as well. We've done that. Yeah, so that's, yeah, I'll have a look afterwards and see why that demo kind of half done, like it worked all the way up to the Redpanda bit, and then I'm not sure what happened after that, because I've had it. I said it like I had it working a couple of days ago all the way through, so I'm not sure what's unhappy with the config.
No risk, Mark. I think it's live demos, right? So demo codes are not
live. I've never seen that error before. That's my first one with that. So just to wrap up our talk. So yeah, this is some information about Pinot and who's using it, and then same thing for Redpanda. Just to give you a summary, so hopefully you've seen that we can build these applications to help users do something. So I guess in our case, the user would be maybe like the Wikipedia operations team, and they're trying to see like what's going on. I mean, you can imagine they would be like, hey, is there suddenly a surge in people editing stuff? I thought like a more interesting thing would be like, hey, can we suddenly see like new users coming in and being really prolific? And can we like encourage them to keep using it? But given that most of them are bots, I don't suppose a bot is going to be impacted by a motivational like speech on being sent some swag by Yarden. So that might not work quite so well. But the properties of these apps, we get the data needs to be fresh. It needs to come in like from Wikimedia in this case, get it sort of all the way through, and allow us to then query. And in our case, our dashboard, which I'll try and figure out what's happened to the demo, and we'll let you know, is running like lots of queries on the same screen, and it keeps on sending them every couple of seconds. So it's only one user, but sending lots of queries. And Redpanda and Pinot have quite a nice integration and work together pretty well to do that. Yeah. So that's me, Mark. You can come and join us on the. I guess I'll have to record a video of this working, won't I? So that you can see everything. Yeah, but yeah, that's a good idea. Maybe we can just probably narrow it down and just do the video, right? Just the coding bit and showing like just capture that bit. That's if you want to join us on StarTree, sg.ai/Slack. There's a bunch of resources on there, dev.startree.ai, and then for Dunith, I'll let you do that bit.
Yeah, so you can find me on Twitter. My Twitter handle is DunithD. And if you have anything related to Redpanda, so we have Slack channel there. You can find the Redpanda Slack there. So feel free to hop in and ask your questions. So, and then we have docs, Redpanda docs links mentioned there. So feel free to jump in and go through the docs if you need anything. Yeah. So
I'm back to you then.
Hi, okay. Thank you, Mark and Dunith, for this meetup. Yeah, it was great. And thank you guys for joining and asking questions on the chat. As I said, the recording of the meetup will be shared this week. It will be uploaded on YouTube, on StarTree YouTube. You can always look for it. If you want the specific link, it will be shared on StarTree Slack. Yeah, and thank you. Feel free, right, to reach Mark and Dunith with questions or in our Slacks. And stay tuned.
I mean, if anybody has any questions now, we still have like 2 minutes.
Yeah.
So correct.
And I mean, I'll see if I can get you a recording of all of it sort of working together, so you can
There's a question here. Okay, so it's not a question.
Yeah, that's the same. It's a follow-up. I think it's a follow-on from the previous question.
Yeah.
Yeah, maybe we can, if I get it working, we can put the video into the what do you call it? Like onto the README of the GitHub. So then, because you already have that, you can just see refresh that. Get the video.
So let me add a follow-up thing. So basically, the key takeaway of this meetup is this combination. It's the Redpanda and you have Pinot. So you have fast data ingestion from Redpanda and you have fast analytics from Pinot. So if you can apply this combination to any industry vertical, like you can have streaming data coming from your IoT sensors and get them analyzed in Pinot and have them projected in streaming real-time dashboard. And also you can apply it to different industry verticals like manufacturing, streaming, entertainment websites, gaming analytics. So there are so many combinations you can apply. So we just try to build a small POC here, but we'll try to get it fixed as soon as possible and we'll share the recording. So yeah.
Cool. All right. Thanks, everybody.
Perfect. Thank you, everyone. Bye-bye. Have a nice day. Good night. Good morning.